All right, so what we're going to be looking at today is using our percent composition as a conversion factor. So what we talked about last week was we talked about percent composition. And just a reminder of what percent composition is, so we did have a formula. We said that our percent composition is equal to the mass of the elements in a compound divided by the mass of the entire compound or molecule. And we can multiply that by 100%. And so this was our equation, and we calculated a bunch of different compounds. We looked at water, we calculated the percent of hydrogen and oxygen, and we calculated a couple other compounds as well. So what we're going to do is that we could actually use our percent composition as a conversion factor. So here are a couple ideas that we are going to be looking at. So one of the key ideas is that you can use percent composition to calculate the grams, which is of course mass, of any element in a specific compound. So this is what we're going to be doing. Now, to kind of get started and thinking about this, what we're going to do is we're going to look at an example. And with this example, I'll kind of talk you through the example, and then I'll write down some steps on how to do it, and then we will solve it. So here's our example. Let's say that you poured yourself a cup of water, and it contained 300 grams of water, which we know has a chemical formula of H2O. And what we want to know is that within that cup, how much of the mass is hydrogen and how much of the mass is oxygen. So let's think about our steps. There are actually 3 steps that we can use. Step number 1. What you are going to do is you're going to find the percent composition of the compound. Find the percent composition of each element in the compound. Now to do this, we can use our molar masses and we can use information from our periodic table. So that's going to be our first step. Our second step that we're going to do is we're going to create a conversion factor assuming we have a 100-gram sample. And this will make more sense when I show you. Once we have done those 2 steps, our last step that we're going to do is set up the problem using dimensional analysis. So let's go ahead and take a look at our example and use these 3 steps to solve. So again, the first step that we want to do, step number 1, is we're going to find our percent composition of water. So my first step that I'm going to do is I'm going to find the molar mass of the entire compound. When we look at this, it is composed of 2 hydrogens, and each hydrogen has a molar mass of 1.008 grams per mole. It's composed of 1 oxygen, which has a molar mass of 15.999 grams per mole. Now remember, these values right here, my 1.008 and my 15.999, come from my periodic table. If I add those values together, I get 18.015 grams per mole, and that is my molar mass of water. Now what I'm going to do is I'm going to take my individual mass of hydrogen and oxygen and divide it by my total to find my percent composition of each element. I'm going to start with my oxygen. So I'm going to take my molar mass of my oxygen, which is 15.999 grams per mole, and I'm going to divide it by 18.015 grams per mole, and then multiply it by 100. This is going to give me 88.81%. Now, since we only have one other element left, both of these, both hydrogen and oxygen, should add up to 100%. So I could take my hydrogen, I could take 100% minus 88.81%, and that'll give me my percent of oxygen, of hydrogen, which is 11.19%. So these are my two percentages. This is oxygen and this is hydrogen. So we're going to be using both of these in our second step. Okay, let's look at step number 2. Step number 2 says that we're going to assume a 100-gram sample. What that means is that assume you have, based off of these values, 100 grams of water. If you have 100 grams of water, so if you have 100 grams of water, this tells me, based off of this percentage, that I will have 88.18 grams oxygen and 11.19, whoops, this is 81, not 18, 9 grams of hydrogen. Based off of that, we could create some conversion factors. So remember, our conversion factors are a ratio that show the relationship between two different things. So to create our conversion factors, we're going to take the each one of these grams and put over 100 grams of our compound. So what we end up getting is 88.81 grams of oxygen per 100 grams of water, and 11.19 grams of hydrogen per 100 grams of water. Now that we have our conversion factors, we can start plugging this in using dimensional analysis. So step number 3, let's go back to our original problem. We have 300 grams of water. We want to know the mass of hydrogen and oxygen. So you're going to start with what you know. We know that we have 300 grams of water. Notice that each one of my conversion factors have grams of water in my denominator. That's really important because those units are going to cancel out. Now, if we start with oxygen, I can set up my conversion factor, and I could say 100 grams of water. It's going on the bottom because remember, these are going to cancel out, and 88.81 on top. So we're going to have grams of oxygen. This tells me that in my 300 grams, if I multiply by 88.81 and divide by 100, I'm going to get 266.43 grams of oxygen. And so that's how much oxygen makes up the 300 grams of water that is in that cup. Now, you could set up the problem again using hydrogen. That would be completely fine. But because there are only 2 compounds that we're looking for, they should add up to the total mass. So we could do something similar to what we did up here, except you're going to take your 300 grams of water, and you're going to subtract your mass of oxygen, and that will be equal to your mass of hydrogen. So here are our two final answers. The vast majority, which makes sense because it is a higher percentage, is oxygen, and the rest is hydrogen. Let's go ahead and take a look at one more example. Here, what we're going to do is we're going to calculate the mass of nitrogen in a 125 gram sample of ammonia. Have a little picture right here. Ammonia is actually a common substance in fertilizer. It is also used in Windex, so that very kind of distinct smell of Windex, if you've ever used it to clean your windows or a mirror, that is ammonia, and it evaporates very quickly. So what we're going to do is this problem is slightly different because it's not asking for the it's not asking for the mass of nitrogen and hydrogen. It's only asking for nitrogen. So this actually makes our work a little bit easier. So what we want to do for this problem is we actually only need to find the percent composition of nitrogen. We don't have to worry about hydrogen. Now we still have to calculate the whole molar mass of the compound. So let's go ahead and step number one, we're going to find the percent composition of nitrogen. All right. So find your percent composition. We're going to use our handy dandy periodic table. Let's first find our molar masses. So we have ammonia, NH3. Nitrogen has a molar mass of 14.007 grams per mole. And we have 3 hydrogen. So I'm going to multiply that by the molar mass of hydrogen. And I end up getting a molar mass, I'm going to write this down here a little bit, of 17.031 grams per mole. Now we only need to find our percent composition of nitrogen. So our percent nitrogen is going to equal to our mass of our individual nitrogen, which is 14.007 grams per mole, divided by the molar mass of the entire substance, which is 17.031 grams per mole. And then we're going to multiply that by 100. And that's going to give us our percent nitrogen. We end up, if you plug that into your calculator, getting 82.24% nitrogen. Step number 2, we need to set up our conversion factor and assume a 100-gram sample. So if we have a 100-gram sample of ammonia, that means that we have 82.24 grams of nitrogen. Because, again, if we have a 100-gram sample, 82% of that, 82.24% of that is nitrogen. So 82% of the 100 grams is going to be 82.24 grams. Let me just go ahead and set this up as a conversion factor by putting these as a ratio on top of each other. So we have 82.24 grams of nitrogen over 100 grams of ammonia. Now what we're going to do is we're going to solve our problem using dimensional analysis. We start off with what's given in the problem, 125 grams of the entire substance. So 125 grams of ammonia. 82.24 grams of nitrogen. My 100 grams of ammonia at the bottom. Notice again that my units cancel out. That means that 102.8 grams is nitrogen. Now again, we could easily have calculated hydrogen, but the problem wasn't asking for hydrogen, so I only had to calculate my percent composition of nitrogen, and I only had to plug this in to solve for the mass of nitrogen. Didn't have to worry about hydrogen in this example at all. So 3 simple steps. Percent composition of each compound. Assume a 100-gram sample and set up your conversion factor. And then plug in your conversion factor using dimensional analysis. So you guys have some practice problems doing this homework. Just a heads up, these practice problems are due Tuesday at the beginning of the period. I will see you guys then.